Komið sæl, Sigurður hérna, leiðtogi bílgreina hjá Iðunni. Við erum stödd hérna í Gautaborg, réttara sagt á Automässan, sem er hér reglulegur viðburður, og ætlum að skyggnast aðeins inn í framtíðina í bílgreininni. Sjá hvað er nýtt og hvernig framtíðin kemur til með að líta út, hvað varðar verkstæði og annað slíkt, og einnig munum við kíkja aðeins á skemmtilegt verkefni sem mun mögulega sýna okkur hvernig framtíðar fólksbílar munu líta út.
So my name is Gabriel. I'm a manager for Chalmers Formula Student and also the lead chassis designer. So short about Formula Student, it's a student-driven engineering competition where universities from all around the world every year design and manufacture a car that we then bring out to different competitions in Europe to compete against each other to see who's manufactured the best car. Some of the highlights of our car, for example, here is the decoupled suspension system. So we have individual control of the heave and roll of the car, which gives us great flexibility when we want to tune the car to maximize the grip we can get from the motors. When we come to the motors then, this is a four-wheel driven car. So at each motor, each wheel we have a hub motor delivering 34 kilowatts. So roughly this car can be put out 200 horsepower to a car that weighs 200 kilos. Other highlights of the car is that we're using a full aerodynamic package, so we generate enough downforce at 98 kilometers an hour, I believe, to technically drive upside down. However, we've never tested this for safety reasons. Other highlights of the car is that 97% of this car is manufactured and designed by us students in-house. So this is a great opportunity for us to learn what we're going to be doing in the future at future companies. We're also doing a carbon fiber monocoque. So the chassis of this car is a very lightweight construction of just 20 kilos, but strong enough for impacts of up to 40 Gs. We're also using a high voltage system for the drivetrain that we have developed ourselves, so inverters and battery, running at 580 volts. In total, we're only allowed to deliver 80 kilowatts, but technically we can deliver up to 136, but not on competition. So one of the biggest highlights for this year, one of the major changes we made from last year, was the introduction of driverless. So we have a LiDAR in the front, which is the eyes of the car, and in just 1 year of development we managed to get a car to drive autonomously around a racetrack, managing to know what speeds to go at and where to brake for corners and so on. And this is one of the major focuses for next year. So this has involved a lot of development for autonomous braking systems, autonomous steering systems, and then the entire control algorithms for how to optimize the driving of the car on track to get that best performance out of it. So about the motors, we have, as I mentioned, four-wheel drive with individual control of each tire. The power of individual control of each tire is that we can torque vector. Essentially, when we're taking a sharp corner, we can send much more power to the outer tires than the inner tires to snap the car around the corner without losing much grip. We also have the ability to use regenerative braking. So for when we're coming for a corner, we can use the motors instead of the brakes to regain as much energy as possible into the battery, which allows us to push more power out when we come for the next lap without risking that we run out of battery before the end of the race. So we're running on in-house designed and in-house manufactured carbon fiber rims. Since rotating mass is the enemy of acceleration, we want to reduce as much rotating mass as possible, and therefore we designed these carbon fiber rims. On the table here before me, we have a lot of 3D printed parts. So in the car, a lot of the parts are 3D printed in different metal alloys. The reason we do this is because it's a really nice way to weight optimize the car. So we're using topology optimization software and methods to create parts that look like this, which is a part that we would generically not be able to design on the top of your own head. But the power of this is the flexibility, and printing time is so much shorter than the CNC times. So these parts will not be able to be manufactured by traditional methods. It also saves us a lot of time during manufacturing, that we can get 3D printed parts that are, say, 90% complete, and then we only have some finishing touches before we can assemble them onto the actual car itself.
Okay.
So when we're working on a car, since we're running a high voltage system, there's a lot of things we need to keep in mind when working with it for safety reasons. So for one, there's only a few people allowed to operate the high voltage system, the only ones that are certified to do it. And to ensure that the rest of the car is safe for people to touch, we have to ground every piece of metal that can come in contact with someone. So for example, these are some of our linkages where we're using carbon fiber tubes and then 3D printed inserts in the ends. And as you can see, we have copper wires running through these carbon fiber tubes, making sure that we have a good connection between the metal parts, which allows that the wheel package on this side is properly grounded to the chassis on this side, which in turn is grounded to the high voltage system's ground. So further on safety when it comes to electrical parts of the car, we have a shutdown circuit in the car, which is essentially one long series of checks that the car will go through, and if any of those trigger, the entire car will automatically shut down the high voltage system. These checks involves things as the stop buttons here on the dash for the driver and on the sides for people around the car, but also these interlock wires that run here. The purpose of these interlock wires are that if they were to break, that means that the motor has come off the wheel, or essentially the entire thing has come off the car. And these will always break before the high voltage cable. So in case we were to be in a collision, these electrical wires would never be exposed to the high voltage system, because as soon as this motor were to break away, the entire system were to shut off automatically to ensure safety of everyone around the car and for the driver himself. So thank you for listening, hope you find this interesting, and I hope that you will finding more of these technologies on future productive cars. Thank you so much.
My name is Thomas Lindblad and I work for ProMeister. We educate mainly for Mekonomen and Meka in Sweden. What we have here is we're in our trailer, which we use as a training facility going around the country. And today for the fair, Automässan, we are converting this VW Type 1 for electric. So it came in as with a combustion engine and everything in it, and it's gonna end up fully electric with also heating electric. So it's gonna be an electric car by the end of the week, Friday evening. So the kit from EV Europe, which we are using here, comes with this box to put the batteries in. So it's just a shell basically to make it a bit safer. And then we have two of these Mercedes battery modules, 52 volts each nominal, so we get 130 volts something when it's fully charged. It comes with a BMS and control system for everything, and then you have to basically to rig everything up and make cables. You do that yourself and you do all the cabling. Here is chargers, so you can charge it on a public station or at home with just a socket, and you build everything that together. Heater, 1200 watts heater, so it's a heater and a fan, runs with a thermostat in the car, and the engine is 140 horsepower engine.
So this is a alignment check. So if you have like one drive-in in a workshop, for example, you can drive every car through the alignment control. So you have like the towers, you put those in when you drive through, and the lasers, they feel when the car is coming, and it also takes your plates on the car. So you get the car info
Directly.
Yeah, directly, and the values from the manufacturer on the alignment. So when you get a report from every car, they can see it's green, yellow or red. Is it red? You have alignment. It's yeah, you need an alignment. Yellow. It's good to you can measure the car to see if you need an alignment, because the tires are very expensive these days. So the customer can not earn money, but save money by to save the tires, so they save money. And the workshops, they get more jobs on the alignments.
And faster.
You
get data on.
Yeah, exactly. Because not every shop, but most shops, they go and measure the tires. They can do it anyway, but if the alignment is wrong, often the tires are bad as well. They go like hand in hand. So this is a very good way for the shop and the customer, I would say. So I would say this is it's a good investment for the shops.